Hello everyone and welcome. Today we're going to cover the tasks that are in the file input and output. And the very first task that we have is tread lightly, she is near. So here what they want us to do is they want us to write a function that reads a text file. It's supposed to read a text file, so whatever file that you give it, it should read it and then it should print it out to the standard output. And the specific one that they want is the POSIX standard output. They've already given us the prototype that they want us to use. So that is what you're going to use. We're going to have that also in the main.h file, which will contain all the header files and all the prototypes that we have and any other functions that we'll be using. The other thing that we have that we're supposed to make sure we have is the letters, or the variable called letters is the number of letters that it should read and print. So that is the other thing that we need to implement in the solution. The other thing that we need is it should return the actual number of letters that it could read and actually print to the standard output. So that is the other thing that our solution needs to capture. If the file cannot be opened, it should return 0. So we need to also implement that. If the file name is null, we should also return 0. And if the write system call fails or does not write whatever we expect or the expected amount of bytes, then it will also return 0. So this is the file that they've given us. It's called requiscat, and this is what it contains. So this is more or less like the text that our file should read, or the text file that we're reading from. This is what we should read, and then this is also what we should print as well, together with the actual number of letters that it has printed, this one over here. So those are the two things that we need to return, or our solution needs to return. They've also given us the main.c file for this task, and it is here. This one, the one that I have highlighted over here. So what I've done is I've already put all these files and the solutions that I have in my Visual Studio. I've already opened it, and these are the files. So remember, the first thing you need to do is create the repository if you've not created the repository, and then also create the directory. And the specific directory that you're using in this specific question is this is the directory. This is the directory's name, and it should be contained in this repository. So for this solution, the file or the solution should be in a file called 0readTextFile.c. That is what you should do. And before you even start, always make sure you have your readme. As always, I have my readme as the title of the task and whatever it is that you're doing. So this is my readme file. I've already created it, and your readme should not be empty. So note, your readme should not be empty. It should contain at least something, and mine contains this. So I've already created the 0.main file, which is the same as is on this other side. I've just copied it and pasted it on this side so that I'll now be able to work on the solution. Yeah, so the next thing I want to do is create now the solution that they want us to create. I've already gone through this, so I've taken a bit of time such that I'm able to just go direct to the point in this tutorial. And this is what I have implemented. So what is happening here, always remember to go back to the requirements that they want us to do. These are the requirements. So whatever it is that your solution is, it should contain each and every single bit of these requirements should be met. So let's jump into it. So this is the header file, sorry, the prototype. This is the prototype, and as you can see, it is the same prototype that I do have here on line 11. So your prototype is the same prototype in the solution. So we can start. So the first thing that we are doing is we defined the function, which is what we are given, as I've mentioned. And what it is going to do is, it's just going to read a text file, which is what they want us to do, and then store the contents in a buffer. And then after that, it should print now the contents of the buffer to the standard output. So in a nutshell, that is what it should do. Read from a text file, store the content that it's read in a buffer, and then print that specific content in the buffer into the standard output. So in a nutshell, that is what we should implement and what we should do. So the first thing we've done is we've initialized an integer called fd, which is the file descriptor that we're going to use, and then we do have two variables that we are initializing, which is underscore read and underscore write, which we'll get to figure out what it's going to store later on. And then the next thing is we are also initializing a pointer, which will be a pointer to a buffer that now will contain the specific characters that are in the text file that we are going to read. So what is happening? The first thing that is happening is we are checking if the file actually exists. And if the file doesn't exist, then we should return a 0. Or if the file name is null, we should return a 0, which is this. This is the very first thing that we should implement. So that is implemented over there. So the next thing that we are now doing is opening the file, and we are going to use the open system call to open the specific file, but we should only open it in read only mode, which is the mode that we should read it in. So this is doing that. We are opening the file, which we do have, and here remember we have passed the pointer to the specific file that we want to read. So this is that, and we are only opening it in read only because we want to read what is in that file. We don't want to do anything else. We don't want to write. We just want to read the content that is there. And if there is a problem opening or it actually fails, it can't be opened to be read, which is this, then we should return 0. So that is the other thing that we've implemented. So after we have opened that file, the next thing we need to do is we now need to put this content that we have read from into a buffer for us to actually use it later and print it out to the standard output. And we use malloc to dynamically allocate memory location for the specific text that we have read. And how we do that is we do have we do know the size of a character. We do definitely know that. And here we are using letters, and letters is the specific letters is, how will I say it? Letters in this case is the number of letters, yes, that it should read or it can read. So that is what we have over here. And if the buffer is null, that means there's nothing contained in the buffer, which would indicate that the file was not read from. Then that indicates there's an error and we should return 0. So that is the other thing that we are supposed to implement, which is this: if the file cannot be read, we should also return 0. So far so good. We have implemented this that I have highlighted, where the file cannot be opened or read in our solution, and we should always return 0. So this is us creating the buffer. So that is that. And the next thing that we are doing is we are now using the read system call now to read the contents of the file into the buffer that we have created dynamically. And this is the buffer we've created. So here we are creating we are reading the contents using the system call. And if an error should occur, which is this: if there's an error, if an error should occur while we are reading, then let us free the buffer. That is what is happening here. Let us free the buffer. We close the file descriptor and return 0 to indicate that there was a problem somewhere. So that is very straightforward. When you read, if you encounter any error, close the buffer, free the buffer such that the buffer does not contain anything, and then close that specific file descriptor. So make sure you've gone through the specific system call that you're supposed to have understood, and make sure you understand the specific arguments it can take and the flags that it can take. Yeah, so here we've used the read system call. Now, We've opened the file, we've created the buffer, and we've read the contents of the file. The next thing we need to do now is print it out to the standard output, and we use the write system call in this case, and that is what is the final step. So we're just going to use the write system call to print the contents of the buffer to the standard output. And if there's any error, which is the next thing that we're going to do, if there's any error, what we should do, free the buffer and close the file descriptor and return 0. So that is pretty straightforward. So the next thing that we should do is, after successful completion, we should always close the file descriptor. If everything goes well, close it and make sure that you return the number of letters, which is this, return the number of letters that we have read and we have printed out to the standard output. And it's as simple as that. Each and every single thing that we have been told to implement on this side, we have. So let us move to the next question. And as a disclaimer, I will point out and say that there are very many ways of implementing this solution. This is what I have used, and I'm also trying other ways of doing it. So even if you've already done use, don't stop at that. So the next question that you have is, you're supposed to create a function that creates a file. We've already been given the prototype that we have. We know that the file name is supposed to be the name of the file to create, and the text content is a null terminating string to write to the file. So they've already broken down what the prototype means. So we can move on, and we're being told that we should return 1 on success and -1 on failure. And failure can be if a file cannot be created, if a file cannot be written to using the write system calls, if it fails, and any other instances that you can think of that will indicate failure of the program. So the next thing that you're supposed to do is, the created file must have this specific permission, read and write. And if the file already exists, then don't change the specific permissions. And if the file already exists, truncate it. I hope you understand what truncate. It means cutting it, more or less, in simple language. And if the file name is null, which is this, the file name is null, that is an error. So we should return -1. And if the text content is null, then we should create an empty file. So I already have my solution. I've already created the 1.1 main.c file. I already have it there. So this is the solution that I have for creating the file. So what is happening in this solution? So in a nutshell, the code will define a function called create file. So this is the prototype that I've already given us. It's called create file, and we do have the given file name, which is what it will create a file with a specific file name that it has, and then it will write the content to the contents of a given string to the file, and the specific file is the one that is specified in the name. And if the file already exists, then the content in the file is truncated, which is this, what they're saying here. If the file already existed, then the content should be truncated. So basically, this function will take in 2 parameters or 2 arguments: the file name, which is the name of the file to create, and the text content that will be written to, which is the actual content. So what is the first thing that we do? So the first thing that we do is we open the file. So this is what is happening here. We are opening the file using the open system call, and we also have flags. So the first thing that you're passing is the name of the file. We've passed it, it's called file name, and we want to create the file. So this is what you're using, o_create flag, and it specifies that the file should be created if it doesn't exist. And the next flag that is there is the o_write only flag, and it specifies that the file should be opened for writing only. So remember this is the pipe. A pipe, in this case, it's a bitwise operator, and what it's saying is we want to create a file and at the same time create it in read only mode. So it will work on these two first, and the contents of this is what will be passed to the next flag that you do have. So the next flag that you have is the truncating flag, and what it does is it specifies that the file should be truncated if it already exists. So if these two are not met, then that means the file already existed. So what will happen is it will be truncated. And the very final parameter, which is the third parameter, which is this 0600, it just specifies the specific file permission, and the specific file permission that they want us to use is this one, RW, and that is represented with 0600. And if we cannot open the file, so that means the file is, the value that it gives us is -1, which is what we had initialized here, file, an integer file, and we had initialized it. We had created we had declared it and not initialized it. And so what you're saying is if file contains -1, which indicates an error, then let us return -1 to also indicate an error as well. Yeah, I hope you got that. So that will meet this specific specification that they want us to meet. This one over here, return -1 on failure. So the next thing that you're supposed to do is move now to the content, because we've already created the file, or if it already existed, we've opened it and truncated. So if the text content, or if there's nothing in the text content, if it is null, then the function should write the contents of the text content to the file using the write function. So that is being implemented here. We're saying what is in the text content. As long as the text content does not contain anything, let us write content into it. And here we're using the write system call, and we're passing in the name of the file, not the name of the file, the specific success or failure of the file, the text content, and in this case the count of the whatever is contained in the file, the count of the characters in the file. Yes. So what is going to do is if the write operation, if the write system call fails, then it should give us -1. So where is that being implemented? It is being implemented here. So whatever results will be obtained from write will be stored in a value called result, and if it indicates it should be a positive integer. So what that means is if the write operation fails, the number of bytes written to is not equal to the length of the text content. So in short, there will be a discrepancy between the two, and what we should do is we should return -1, and that is here. And remember, each and every single time we open a file, we need to close it, and that is happening here. And if everything is okay, then we should return we should return 1. So because that is what they told us, return 1 on success. So that is the last bit that we have implemented over here. So now we can move to the next solution, which is supposed to be the solution for this task, that we're supposed to write a function that appends text to the end of a file. They've already given us the system. Sorry, they've already given us the prototype. Yes, the prototype. So let us open the solution for this one, and it is here. This is it. So let us look at what is happening. We already have the append text to file function that is supposed now to take 2 arguments, and these are the 2 arguments of file name and the text content. So the file name is a string that represents the name of the file, as you've seen. Then the file is the file to which the text is supposed to be appended, that specific file. And the text content, which is the text that will be appended to the file. So here we're using the pointers, not the actual content. We're using the pointers to the file name and the pointer to the file that contains the text that we're supposed to append. So the first thing that it's going to do is it checks if the file name is null. That means like if the file name has not been provided or if there's nothing in the file name. So if it is missing or if it is null or if there's nothing, then the function returns -1 to indicate that there is a problem or there is failure. The next thing that we should do now is we should now open that specific file that is going to receive the string or the content that is being appended. So we open it in append mode, and this is what we're going to do. We use the open system call, pass in the name and the two flags that we want to use, the write only and the append flag. So those are the two that we're going to use. And if the file cannot be opened, this fd, which is the file descriptor. If it's -1, it indicates a problem because -1 is a value that's usually retained for unsuccessful operations. And if it is unsuccessful, it indicates failure, and we should return -1. So that is what they want us to do here. Return -1 on failure and 1 on success. So 1 is what we will return at the very end, which is this, once we have finished our working and we have closed. So those are the two bits where we have implemented this requirement that they want us to do. The other thing they're saying is we should not create the file if it does not exist. So there is no place here that you're going to create the file, and if you were to pass the create flag here, then that will be different. And we saw this in the previous solution, this one where we created the file if it didn't exist and opened it in write only mode. So here we are only opening the file and writing to it because we are supposed to ensure that it has already existed prior. So the next thing that we're going to do is we're going to check if the text content is null, and that is happening here. So if there's no text content, that means it is null or it is missing, then we should simply close the file descriptor because now there's nothing to append to, and we should also return 1, which will mean successful completion because the text does not exist, so there's no text to append. And the final thing that we should do after we have opened, which is what we now need to do, is append text from a specific file to this file that we have opened. That is happening here in this block of code that I have highlighted. And we're using the write system call. In this case, we are passing in the file descriptor that we're using, which is this fd. We are passing in the text the specific file that contains the text, and this is this. And we're also looking at the length of that specific document or text that we are appending into. So that is happening here. And what we're checking is we're checking if the write system call fails. This is this. If it gives us a -1, or if it partially succeeds, and that is here. If it partially succeeds, then the function is supposed to return -1. Otherwise, we should close it and everything should be okay. So here we're just saying if there's any bit of failure on the write system call, let us close that specific file descriptor and return -1 to indicate failure. Otherwise, if everything is okay and we've appended successfully, we are closing the file and we are returning 1 to indicate success, which is what they have suggested over here. So now we can move to the very last task that you're supposed to do, and it is a bit lengthy. And here we're supposed to write a program that copies the content of a file to another file. So this is slightly lengthy. And here we are using this cp file from file tool. And the other thing we should make sure we meet is if the number of arguments is not correct, we should exit with code 97, and print this followed by a new line to the standard to followed by a new line on the POSIX standard error. So here they want us to use standard error, which is different from standard output. Let me open that file. So this one is a bit lengthy, so and a bit it needs you to really understand what you're doing, at least to a greater extent. The other thing we should do is, if file 2 already exists, then you should truncate it. So here what we're doing is, file from is the file you are copying from. This is the name of the file you're copying from. And file 2, this is the file we are copying our content to. So these are the file names, not necessarily function. These are the file names. So if file 2 already exists, then you should truncate it. If file from does not exist, or if you cannot read from it, then we should exit with code 97. So as you can see, they are telling us to use specific values to indicate specific things, and there are also specific error messages that we are being told to use in this case. And they're also telling us that once we have printed each of this error to the standard error, then we should also make sure that it's being followed by a new line. So I hope you're following. We're about to come to the end. And if you cannot create or write to the file that you're supposed to write to, then you should also exit with error 99, print this specific message, have a new line, and all this should go to the standard error. And here they're also telling us that the name of the file is the second argument to be passed to our specific program. And the other thing is they're telling us that if you cannot close a file descriptor, then exit with 100. So we have 4 exit codes so far. We have 97, 98, 99, and 100. And I think this is going to help us in the shell project as well. I think which is coming up, because now the specific code that you have indicates a specific error. So you'll be able to know exactly what is happening where. And the permission that we should have is this. This is the permission. So we also need to make sure we know the value for this. And you must read 1024 bytes at a time from the specific file that we are copying from to make less system calls, because a system call is basically how will I call it? It's when the system wants to perform a specific function. It uses that call to communicate with the kernel and vice versa. And here we're also being told that we should use a buffer. So we need to make sure we use a buffer in this case, and we've been allowed to use the dprintf function. Yeah. So let us jump into the solution. So it is a bit lengthy, but I'll try my best to explain what is happening. And I've tried my best to have the errors at different points. So let's start. So I do have my main function. It is here. And in a nutshell, what it's supposed to do is it will check if the number of arguments that are passed to the program is equal to 3. That is happening here. It's checking if it's equal to 3, if the number of arguments passed is equal to 3. And if not, then it's printing an error message. It's printing an error message in this case. Because they've told us if the number of arguments is not the correct one, then we should exit with this exit code. And the number of arguments that we do have are 3. The first is cp, which is the copy command. The second is the file you're copying from, the name of the file you're copying from, and the third is the file you're copying to. So it will be exactly 3. And if it is not 3, then we should exit with error 97. The next thing that we are doing is creating and allocating a buffer for us now to be able to store whatever we are copying in chunks of 1024 bytes at a time. That will allow us now to be able to copy to the file that we want to copy to. And if the buffer does not exist, then we're supposed to return -1. So if the number of arguments is correct, then it will definitely do this allocation. So it will not be able to move to this next step if the number of arguments is not the correct one. So I hope you got that one. The number of arguments need to be the very correct one for it to be able to allocate memory for a buffer of size buff size. And buff size, in this case, this is buff size. It's 1024, and we've defined that here at the very top. We've defined buff size to contain 1024, which is what they wanted us to do. So now that we've put the correct number of arguments and we've created the buffer, the next thing that our program is supposed to do is it will then go ahead and open the source file. This one, the source file, which is the first argument. Remember, the argument indexed 1, remember we start counting from 0. So here the argument indexed 1, which is going to be the file from, and we are supposed to open it in read only because we are supposed to read only from it. We're not writing and we're not doing it, we're just reading from it. And that is what we are doing here, is opening it in read only mode and checking if there's any error that can occur or has occurred. And if the error has occurred, then we use the error 98, which is what we have at the we have it somewhere, error 98. We've defined that function somewhere and everything that is supposed to happen there. So the next thing that is happened is we should also open the destination file that you're copying to, and it is the second it is indexed to the specific argument, or the specific argument in this case is indexed 2. So here we are opening the second argument and we are using write only, and if it already existed, we truncate it. If not, then we are creating it, and we are creating it in the specific permission that they told us to do, this one over here that I'm highlighting, and the specific code for that is 06664. And if there is any error, then we are using the error 99 function, this function over here that we have created at the bottom. We'll go and look at that. So the next thing that will happen is we're going to enter now into a do while loop. If everything is okay, we've read from the buff size and we've read from the buffer in the specific sizes that we have been told to, and we are reading from the source file and copying it into a buffer and writing whatever is in the buffer to the destination file, and we are using the read system call. This is the read system call. So that is what you're now using here in the do while loop. So we are reading from the buffer in sizes of 1024, which is contained in the buff size, and what we're doing is we're going to read that until we finish everything. So the function enters the do while loop and reads from the buff and reads buff size bytes, 1024 bytes from the source file into the buffer, which is what I've said, and then we write it to the destination. So here, so we should make sure that it has been read and it has been stored in this variable called res0. And if res0 is not containing anything, that will indicate that we've finished reading everything, then we should break. But if there's any error with reading, then we should use the error 98 error, which is this error, the exit code that they've told us to use. So that is going to happen there. So the next thing that we're going to do is, if this has been successful, then we are now writing whatever is in the buffer to our file now. So our file in this case is called file 0. We're reading from the buffer, and this is what we are using to read. This is what he is being contained to read. And if you cannot read correctly, then we use error 90. If we cannot write correctly, we use error 99. So if there's any error with writing, we use error 99, which is this one, the exit code, to indicate that there's something that is not correct somewhere. So if at the end of the day, if the read and write operations fail, then we are using 98 and 99. So that is being implemented in this section of code over here. And the loop will continue until the number of bytes read from the buffer is less than 1024, or we've exhausted it if there were exact multiples of 1024. So at the end of it, finally the function will close both files because it needs to close both files. Remember, anytime you open a file, you need to close it, and this is being implemented here. We open the file, so we are closing them using the close system call. And if there is any error with closing, we are supposed to implement and exit with error with code 100 and have this specific error. So that is also happening here. But remember, we've not finished freeing the buffer, so the next thing that is supposed to happen is freeing the buffer. And if everything is successful, then we should return 0 to indicate successful completion. So that is the main function that is happening over here. That is where the implementation of this. But remember, we have not created the specific functions for the different exit codes. We have 97, 98, 99, and 100, and that is coming here at the bottom. So here we do have error 98, which checks that the value, which helps if you cannot read, and what it does is it just helps us read correctly, and if there's any error with reading, then this is what we are supposed to do. So I've implemented each and every single error. This is error 99, which is the error that we have when we cannot create a file, or if the right system call to the file to, or the file that we are copying from, failed. So that is being implemented here in this specific code block or function that I have highlighted. And each and every single time we are doing this, we are creating, or we are using the dprint function. We're using the dprint function to print the specific error to the standard error output, to the standard error, and we are also going to free the buffer that we are using, because now we've encountered an error but there was content in the buffer, so we need to free the buffer as well. And the last function that I've implemented in this case is the error 100 or exit code 100, and it's just helping to indicate an error with closing a file descriptor. And that is it. In the next video, I think I will have the advanced task. I'm going to look at this, the one for the elf. I'm going to do that, and I'll provide the solution in the next video. Until next time, happy coding.